What's up, everyone? It is time for the January 21st, 2025 Earth Science Regents. And like the other ones, I'm going to go through the entire test right now. If you already took this test, then you can kind of see how you did. And I'm going to go as fast as I humanly can. And I have not done this before, so you're going to hear me pretty much figure out how to do these on the fly. And I'm assuming you have full background knowledge of the curriculum at this point. If you don't, go watch my other playlist of the breakdown of all the topics of the curriculum and then come back to this so we can go through it together. All right, here we go. So we're starting on question 1, multiple choice. It says Ceres, a dwarf planet, is located approximately 413 million kilometers from the sun and is located between the orbits of what? So this is the number we need. So we're going to go to 413 million kilometers from the sun on page 15. We're going to go to our reference table, go down here. Now we're going to go mean distance from the sun. Right here, we're going to look for 413 million, which would be right in between Mars and Jupiter. So that's how you would get that. Looks like 3. All right, number 2, observations made by astronomers indicate that the light from most galaxies shows a what? So we have to know that most galaxies in the universe are going away. They're moving away from us. So that gets rid of that, and that gets rid of this. Anything that's moving away is a redshift. This is literally a memorize, so you're just going to have to remember that. Number 3, compared to the Jovian planets, so compared to them, the terrestrial planets are what? So the Jovian planets, this is like Jupiter, and the terrestrial planets, this is like Mercury. So just based off that, you should know Jupiter is the biggest planet. Now, if you don't know that, you can use this table again and get all your data. So I would know that these 4 are the Jovian, these 4 are the terrestrial, and these 4 are the Jovian, right? So then you can use the data, but you should probably have this remembered, honestly. The big planets are really, really big, and they're low density, so it's saying the terrestrial planets are, so these are going to be your small, made of rock, high density planets, so it's going to be 4. Number 4. Listen, I don't even have to read this because I see the word Foucault pendulum and I know it's Earth's rotation, right? So I'm going to read it anyway. The apparent shift in the direction of the Foucault pendulum is a result of what? Yeah, spinning of the Earth on its axis is going to be the answer. That you have to remember, Foucault is for rotating. Number 5, which motion causes some constellations? Again, I see the word constellations and I automatically know it's because the Earth revolves around the sun. And that's just because I have memorized that the constellations change throughout the year because the Earth revolves around the sun. It also says winter and summer, so that's your seasons, which means we're going around the sun again. So there's another clue there to know that if you forgot. Number 6, which set of New York State locations would have the greatest difference in the altitude of Polaris? Okay, so this one, once they show a bunch of cities for the New York State locations, I'm going to go to page 3 on the reference table, and I'm going to start looking at these. But instead of going here and being overwhelmed, what I'm going to do is I'm going to go here, and I'm just going to compare each choice, because otherwise we don't really know what we're looking for. So we're going to look here. We're going to go back to our thing, and we're going to check these. So the greatest difference in altitude of Polaris. So we want the greatest difference in latitude, because Polaris, anything to do with Polaris is going to be a change in latitude, and it only works in the northern hemisphere, remember. Okay, so we're going to go Niagara Falls and Albany. We're going to find them, and this is going to maybe take you a little bit to find these. So Niagara Falls and Albany. Niagara Falls, Albany, so this is choice A. They're pretty much on the same latitude, so that is not going to be the answer probably. Rochester and Ithaca, so we got Rochester here and Ithaca here. So this is going to be B and B. So there's a little bit of separation there, so that could be an answer. We're going to check them all. C is going to be Riverhead and Messina. So Riverhead is down here, and Messina is, if we could find Messina. Am I not scrolled? Yep, that's why. Look at that separation. Wow. So that's probably going to be the answer because Messina's way more north than Riverhead. But we'll check Plattsburgh and Jamestown just in case. Plattsburgh is here. So this is choice D, and Jamestown is going to be here. So that's pretty good separation, but Riverhead and Messina win by a lot. So that's going to be 3. Okay. Which process of the water cycle allows water vapor to enter the atmosphere? So we want water vapor to enter the atmosphere. So we want it to enter the atmosphere. We want it to go up. So it's going to be transpiration and evaporation bring things up. Number 8, a relative humidity and dew point question. Okay, so we're going to go to the reference table because we know when we see these percentage types of questions here, we're going to want to go to this page right here. And we got to rotate this so we can see it correctly. All right. So let's check it out. What is the dew point when the dry bulb is 19? Okay, the dry bulb is 19 and the relative humidity is 73. So first we're going to use the relative humidity 73 with our dry bulb of 19. So go to 1973 on relative humidity. 19, oh, they did an odd number. So we're going to go in between here, and we got to find 73, which is going to be here, which means the difference is 3. So now we can go 19 and 3 on the dew point chart. 19 right here, 0, 1, 2, 3. So it's going to be 14 degrees Celsius, and then we hope it's the choice. And it is, so we get it. My advice for these types of questions would be make sure you solve it before you look at the answers, because then you know for sure that it's the answer. Don't look at them first. Number 9, the diagram below shows a weather station model. So what is the air pressure in millibars indicated by the station model? So for this is air pressure. Now, if you didn't know that that was the air pressure, you can go on the reference table and go to your station model cheat sheet, which is right here, and know that the top right-hand corner is barometric pressure, which is the air pressure, and it's 150. So the code for this is a 0 to 4, you put a 10 in front, and if it's a 5 through 9, you put a 9 in front, and you're looking at that first digit. So it's a 1, so I'm going to put a 10 in front, and then rewrite my number, and then put a decimal between the last 2. So there's my answer. All right, number 10. Okay, I see star trails automatically. That is Polaris. That is just something you have to remember. So all the other stars look like they're rotating around Polaris because Polaris is directly above the Earth's North Pole. So it looks like it stays in the same spot. Easy question. Okay, I know this is a time zone question because I see they have the time zone shaded in a nice way. So it's 10 a.m. in New York City. So I like to label it. So that's over here. So that means this whole section here, the Eastern, is 10 a.m. They want to know what is it in Seattle, Washington. We got to get to this section. Here's the section. So we're starting here. We got to go. There's another one, and then finally here. So the way I like to remember it is east increase, and then west is less. So we're going to start at 10 a.m., and each is 1 hour difference, 1 hour per 15 degrees longitude. So ready? Next one, we're going to the west. So this is 9 a.m., this whole section. And we go again, 8 a.m. So that means in Seattle, it is currently 7 a.m. That's very easy time zone question. Number 12. Which diagram correctly matches the location of the sun with the shadow of the stick? Okay. So like, look at this one. If the sun's here, it's going to hit the light's going to hit the stick and the shadow's going to go this way. So this is wrong. If the sun's here, the light's going to hit the stick and the shadow's going to go that way. So that's wrong. If the sun is there, it's going to hit the shadow and go this is right. And then here, if the sun's here and it hits the stick here, the shadow's going to go that way. So that one's wrong. It's always opposite the direction of the sun. So it's 2. All right. We have a low pressure system, and there's some fronts here. We got a cold front and a warm front, and it looks like there's an occluded front over here. Which sequence is the correct order of the occluded front? So the way I like to do this is first the cold front and the warm front are sort of like this. So this is going to be step 1, classic low pressure cyclone. And then it's going to start to like meet up at the top and then zipper down. So it's going to go 1 here, then 2, then 3, and then 4. So this looks like B, A, D, C. So then that's going to be that one. That's like a very specific weather question. Number 14. Which map shows the most likely direction of flow of the jet stream? Okay, the first off, anything in the United States is going to go from the west to the east in terms of weather. So anywhere the arrow, any of the where the arrows are going to the west, this is wrong, and that's wrong automatically. Okay. Then they changed where the warm and the cold is. The warm is going to be more down south, and the cold is going to be up north. So this is going to be your right answer. All right, 15. Which statement best explains why predictions for extreme weather events are more accurate today than in the past? Let's see. It's probably because we have better technology. Scientists control weather by using... No. There are fewer extreme weather events? No. Weather conditions change more slowly? No. Yeah. Advanced computer models use weather data to make predictions. That question is very easy. Number 16. We want to maximize the amount of insolation absorbed. So we want dark and rough, and that's just memorize. If it wanted to minimize, you would have picked light and smooth. You can't pick light and rough or dark and smooth. They're like opposites. All right, 17. Uneven heating of the Earth's surface and the atmosphere along with Coriolis effect produces ocean currents with a general what? So they're asking you for direction. So in the northern hemisphere, we curve right. So that's the part you have to remember. So let's see if we can find that. Clockwise flow in northern and southern? No. So a curve to the right is going to be like that, right? So that's clockwise. Clockwise flow in the north and counterclockwise in the south. This is going to be the right answer. Number 18. Which activity contributes to the highest levels of greenhouse gases? So greenhouse gases are going to be from pollution. So we want something to... This is a good thing. Replanting forests is a good thing. Watering farm crops is a good thing. So burning, that's pollution. 19. What is the main reason that locations near the ocean have smaller temperature ranges? So this is really big thing. Anytime you see something to do with the oceans and temperature ranges, this is a question about specific heat. And it's literally the only answer. Water has a higher specific heat than land. That means that areas near the water don't get too hot, but they also don't get too cold. Number 20. Wow, geologic time. Okay. What do they base dividing geologic time in based on? Celestial events? That's like like stars and stuff, so that's not right. Tectonic events? Sometimes. The absolute age of the rocks? No. Yeah, so it's going to be based on the fossils. So that's what they mostly get their data from. So if you go to the geologic time scale and you go to the bottom, you can see all the fossils. See them all? So that one is 4. During which geologic time period were thick layers of evaporites deposited? So this is just a very specific thing. Thick layers of evaporites. So we're going to look for that here. That's going to be an important geologic event. So let's see. Thick layers of evaporites. Thick layers of evaporites. Do we see this? Evaporite basins. What am I missing? During which time period were thick layers of evaporites deposited in New York State? Is it in here? I'm guessing, like, it's kind of weird. Is it this? Salt and gypsum deposited in evaporite basins. What row would this be? This was 1, 2, 3, 4 up from the gray. Wait, including the gray. I have it on 2 separate pages, so it's kind of annoying. 1, 2, 3, 4. So is it Silurian? Guess it is. I mean, it's there. Yeah, that question's weird because it's like not directly there. Wow. I think I hate that question. All right, on that note, oh, 1 sec, I gotta put my reference table back. Okay. All right, we got a P wave and an S wave. So Earth's outer core is inferred to be a liquid because, so S waves can only travel through solids and they get absorbed in the outer core. So S waves cannot travel through it is the right answer. So that is memorizable. I remember it by S waves are solid. They can only travel through solids and they're slow. S for solid, S for slow. 23. Okay, we got a P wave, S wave question. So right off the bat, I'm going to go here. And remember, I'm going to not look at my answers. I hope I could solve this without a piece of paper. A seismograph detects an earthquake that is 5,600 kilometers away. Okay, so automatically, I'm going to go to my reference table, find that. 5,200, 400. So I know I'm on this line right there. Okay. The P wave arrived at 10:36 a.m. What time did the earthquake occur? Okay, so we need to find the P wave time. So we're going to go up here, go right there. Oh, it's on a black line. Look, 9 minutes. It took the P wave 9 minutes. So that's great. So 9 minutes. And the order that you want to know for this is the earthquake happens, then the P wave happens, then the S wave happens. So if this happened at 10:36, the earthquake happened before the P wave, so 9 minutes before. So if you do that, it's 10:27, and that is there. Yay. If they ask like the S wave or something like that, that happens after the P wave, so you would add to the time. Number 24, the Mariana Trench has formed because the Pacific Plate is doing what? So we're going to go to our plates. I'm going to rotate this because we can't see it. Okay, Mariana Trench. Let's see if we can find the Mariana Trench. It is right here. So that's cool. So what does it show us? These squares show us that the one with the square is the overriding plate, and the side that's not have the square is the subducting plate. So the Philippine plate is overriding the Pacific plate. We need to find that. The Philippine plate is overriding the Pacific plate. Or we could say the Pacific plate's subducting underneath the Philippine. Oh yeah, because it's the Pacific plate is, so it's going to be 3. Subducting underneath the Philippine plate. Kind of tricky, but not that hard if you know what the boxes mean, and you get that down here. So you don't have to remember it. 25. Rock primarily composed of which mineral would be most resistant to weathering? So for most resistant rock, we want the highest hardness on the scale because that's going to be the hardest to break down. So we're going to go here. Ooh, did it say rock? Oh no, minerals, easy. Go to our mineral chart. And we're going to flip this again because it's annoying. Okay, now we're just going to look in the hardness right here, see? And we're going to find the highest one. So we're really looking for like these. Garnet, quartz, olivine, one of those. Let's see. Olivine. There you go. Easy peasy. 26. Which agent of erosion produces parallel scratches? Okay, this is just a memorized. Parallel scratches are from glaciers. There's no other explanation for that. Running water is rounding. Wind is pitted like little holes, and ocean waves kind of just generally erode. There's nothing like specific with them, but more rounding. Glaciers are scratches and stuff. 27. Compared to the climate at A, by the way, I've been doing this a long time, so I do skip the top until I get stuck, and then I'll jump to the top and see if I miss something. But for you guys, you should always be reading this top section up here. The map below represents prevailing wind direction over the Sierra Nevada mountains. We got A and B locations. Great. Compared to the climate at A, climate at B generally is what? So let's see. A, we got our windward and leeward side. So there's our mountain range. So this is the windward side. This is the leeward side. So this is the dry side, and this is the wet side. This is the side with the wind. This is the side with like the desert. So A is going to be, they're asking for B. Climate at B is warmer, less precipitation. It's like the desert. So 4. Which graph correctly, half-life. So we're going to go there real quick. Go to our half-life table, which is right up here. And what is it asking for? K40, potassium 40. So we're going to look here. 1.3 times 10 to the 9th. So if it's 1.3 times 10 to the 9th and we went for 2.6, this is 1 half-life, that's 2 half-lives. So if 2 half-lives went by, this is 50% remaining. This one would be 25% remaining. So we got 25% of this and 75% of this, right? Because it always equals 100. So we're looking for 25 gray. So it's 3. Nice and easy little half-life question. Oh, 29. Okay. We got a little sequencing thing happening here. Let's see if we can figure it out. Which rock unit shown in the 3 outcrops is the oldest? So the oldest is always on the bottom. So first of all, we want the bottommost ones. So let's say siltstone layer at the top of location A. So that's wrong because it's most likely wrong. So if this is siltstone, we don't actually know that this is siltstone. Well, you wouldn't know. So the way you would find that out is you have to go to this page here with all the rocks and see the lines with the dots. That's siltstone. So this is siltstone. I'm just going to say silt. So this is siltstone. This is siltstone. This is siltstone. So automatically, the siltstone at the bottom is going to be older than that one. So I know that's out. Okay, so then we're saying the shale layer. The shale layer is the lines. So this is shale. This is shale. I'm only really labeling the ones that they're asking me about. So shale, shale, shale. Oh, there's another shale. So the shale layer at the bottom of B. That looks like it's a contender. So we're going to see if that's different in some way. Conglomerate layer on the top of B. So conglomerate layer, let's just double check what that is. See, conglomerate is the weird rocks there. So if this is conglomerate there, that's conglomerate, this is conglomerate, that's out because shale's under it. So this is automatically not going to be the oldest. Limestone layer at the bottom of C. Okay, this could be weird. Let's check this one out. Limestone there. Limestone here. Limestone here. Okay. Now, here's where this gets weird. We have an unconformity here with the dots, which is sandstone. So this layer here is this, which means this limestone here is this limestone, which means technically this shale would be here. Therefore, this guy is the oldest. So our answer is going to be 2, but I could see why you would put 4. But really, if you're on the regions and you kind of know that the oldest is on the bottom, you would have ran into a problem because both of these are on the bottom, right? So you would have had to figure out what I just said, that this limestone was here, which means this shale is actually under the limestone. So I would say so far, I'm going to put a big circle around this question. This question I would say is the hardest one so far. All right, number 30. The oldest bedrock is found where? So the newer rock is always at the ridge. So this is the ridge, and then the oldest is the further out. So A is the furthest away from the ridge, so that's going to be the oldest. Oswego and Old Forge, located in similar latitudes in New York State, have very different landscapes. Which 2 factors are responsible for landscapes? So it's always going to be the bedrock structure and bedrock composition. Different landscapes. So it's not going to be the age. And the dirt, the soil characteristics is not going to change the landscape. Landscapes are we're talking like mountain, valleys, plains, which are the flat areas, or plateaus, things like that. That's going to be the structure of the rock is going to be like the big thing, the structure, how it's built, right? So it could be like this. So its structure wins, and the composition, what the rock's made of, that's going to be a major thing, because if it's made of harder minerals, it'll break down differently than weaker minerals. So 3 is going to be your best answer for 31. All right, 32. All right, we got a contour map. We got a river. So listen, without even looking at the question, I know this river is going to go this way because the contour lines bend up the stream. So I know Henry Creek is flowing northeast. I didn't even see the question yet. And then this interval is 10 feet. So this is a 300. We're going downhill this way. So this is 290. 280, 270. And then that means this line's 310, 320, 330. There's really not much more they can ask than what I just did. So let's see. Which location would the water be flowing at the greatest rate? All right, I didn't expect that, but that's going to be where it's steepest. So that's going to be here. The water will go faster because it's the steeper hill. The lines are closer together. So it's going to be choice C. A metamorphic rock with banding is described as, wow, that's really the only question they asked about 32. Okay. A metamorphic rock with banding is described as having what? Okay, so you go to metamorphic rock. Check this out. Banding. Okay. Now, what is it asking? Oh, look, it's foliated. Is that what it asks? Yeah. Done. You could check the other three if you're not too sure, but I am sure. The hardness of a mineral is the result of what? If you see the internal arrangement of atoms as an answer, it's going to be right. I'm going to say that with 99.9% confidence. But the way that the structure of the mineral builds itself gives it pretty much all of its physical characteristics. So the shape, the hardness, the breakage pattern, anything like that. The two sedimentary rock formed from organic sediments. So these were once alive. So we're going to go on sedimentary rock, organic, which is going to be your bioclastic. So limestone and bituminous coal are the two. So we got one. All right. We got the Bouvet Island hotspot. Okay. So let's see what it says. It's a remote island located above a hotspot, southwest Indian Ridge. So I already am going to look here. Let's find it. Bouvet hotspot. Where is it? Right there. All right. Just in case we need it. The distance between Bouvet Island and Antarctica is approximately equal to the distance from Earth's surface to what? Wow, this is annoying. So it says it's 1,700 kilometers away. They want you to take that. We're going to go here to this one. And 1,000... I'll rotate this because I'm looking at it sideways, but I don't want to confuse you guys. So check this out. 1,700 kilometers in depth. This is a very annoying question. That's like about here. So if you follow that all the way up, we're in the stiffer mantle. So that's probably the answer. Yeah, the middle of the stiffer mantle. It's about that distance. So you had to use page 10 with that information. Which section best represents the convection currents formed beneath the Bouvet hotspot? Okay. So here's the thing about these. We only care about the tops of the arrows, right? So Bouvet hotspot, if it's diverging, if one plate's going this way and this way, that's diverging. If this arrow is going this way and this is going this way, that's converging. If this is going to the left and this is going to the left, that's probably not the answer. And if this is going right and this is going right, that's probably not the answer. So I'm going to guess it's one of these. And we're going to look. And we're going to see which one that probably is. By going back here. I'm going to look to the right. So you could see the boxes there. The boxes are divergent. So it's going to be number 2. The arrows are going away. Which current would most likely influence the climate of Bouvet Island? So we're going to find an ocean current, which is page 4. We need to find it in that spot. So go here, and we're going to go to that exact spot here. So it's either going to be Antarctic circumpolar current or the Benguela current. I hope both of them aren't there. Good. If they were both there, I would have just had to go back and be more accurate, but they only put one. Okay. All right. Automatically, steep slope. That's a cold front. I mean, that's like all there is to it. Giant cloud, steep slope, CP air. That's cold air. 1. Relative humidity within a cloud. It has to be 100% to make a cloud. So that's 4. These are easy questions so far. Which statement best describes why clouds are forming? Because warm air is pushed up over the cold front. That's the answer. The CP air mesh pushes the MT up, causing it to compress and warm. No. If you look at your acronym for a cloud forming, it rises, expands, cools to the dew point, and condenses. That's how I teach it, RecDC. Don't write RecDC on the test. It's just to remember rise, expands, cools to the dew point, and condenses. So if you're making a cloud, it has to expand and cool, not compress and warm. So 4. All right. Between 251 and 1.8 million years ago, India generally moved which direction? Okay. We have to go to our geologic time scale. And we're going to look at this. See? So what do we need? 251 and 1.8. So like from here to now. India. Why would they put this as a question? That is brutal. There? That's terrible. North and east? Is that real? Am I doing that in a weird way? I mean, I would pick 1. That is terrible. Am I missing something that tells you more information? Yikes. I would say this question stinks. All right, 43. Pangaea is represented on map what? Am I missing something? Oh. There's a map on the next page. That is weird. Okay. Maybe this doesn't stink. Let's go back here. I figured that out a different way. I didn't even see this map. Okay. Between 251 and 1.8 million years. Okay, let's look. 251 and 1.8. Oh, they're all labeled and stuff. This is so easy. Look. India, 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 India. It moved northeast. Great. So it figured out like that. Oops. I was grilling this question before I even. Pangaea is represented on map what? Pangaea is when all the continents were together. So that's going to probably be. Oh, but is it 251 or 200? So now we have to go here. Where's the formation of Pangaea? Look, forming Pangaea here. So this is going to be at like 250 million years ago. So it's going to be A. Did they put B as a possible answer? Because that would be terrible. Be mean. No, they didn't. That makes it easy. Because C, D, and E are already separating, so that made it way easier. Which group of organisms became extinct during the time represented on map A? So extinct at 251. So we're going to look here. Which bar here ended? So it looks like right here is the end of the graptolites. Rest in peace, graptolites. 4. All right. Base your answers to 45 through 47 on the photograph below. We're showing Purcell Sill in Glacier National Park, Montana, composed of the igneous rock diorite. That could be important. Cutting through Precambrian limestone. Okay. Zones of contact metamorphism are indicated. Okay. The rock that formed contact metamorphism of limestone. So we want the metamorphic version of limestone. So we're going to go here. We're going to go to metamorphic and we're going to see which one comes from limestone. And we can look here. Look, metamorphism of limestones, that's going to be marble. So marble, easy. Which minerals are found together in a sample of diorite? Okay, so we're going to go to diorite on igneous. Go here, draw a line straight down, and whatever is in this column in diorite's box is possible mineral inside of it. So we got plagioclase, feldspar, biotite, amphibole, maybe a little pyroxene there, and maybe a little bit of quartz. But mostly plagioclase feldspar, so that has to be an answer. Is any of them not? So it's not potassium feldspar. Go back. Biotite and amphibole. This is the answer. 3. Because it says most likely found together, so the spots with the tiny little bit is more unlikely to be found. The texture of the diorite found in the sill is described as what? Easy. Look, diorite, texture, go across, coarse, non-vesicular. Boom. I have to say this is an easy test so far. We'll keep moving. We'll see if it changes in the short answer. We have a meandering stream. Okay, so it wants to know which location is represented by this cross-section. So there's no erosion or deposition on either side, which means this is not on a meander. This is not on a curve. So it's got to be a straight area. So it's probably going to be A. That looks straight. D is a meander, C is a meander, and B is kind of closer to meander. So it's going to be A. The velocity at a certain point in this stream was measured to be 100 centimeters per second. What size particles will be transported? Okay, go here. 100 centimeters per second there. Go up to the line. So it's going to be pebbles, sand, silt, and clay. Anything equal to or less than can be transported, but pebbles is the biggest. Yeah, look. Pebbles, sand, silt, and clay. 4. What is the name of the feature located at the end of the stream where it enters the ocean? Wow. This right here is a delta, and that just needs to be memorized. A tributary is a small river connected to the main river. A floodplain is the sides of the river that floods, and a watershed is a giant area where all the water flows into the same location. All right, that's the end of the multiple choice. So next up, we're going to do the short answer. See how it goes. So far, this has been an easy test minus a couple of questions. All right, question 51 is on the evolution of stars, and they have this paragraph here that says a star forms from a huge dust cloud and gas cloud called a nebula. Gravitational forces cause the cloud to contract. Before I continue reading this, a good strategy for this, since we know there's 3 questions, 51 through 53, it might be a good idea to read the 3 questions first and then go back and read to see if we could pick out any information. Identify the nuclear processes that produces energy in stars. Okay, so we already know the answer to that. Here's our answer booklet. So we're gonna go nuclear fusion. That's the only nuclear process that's learned in this curriculum. Just make sure you don't write fission by accident. One star that was formerly a sun-sized star but is now in late stage of existence. Okay, so this is going to be on the reference table. So you're going to go here, page 15. So late stage, as you could see, is right here. So here's your 2 answers. You could either write Procyon B or 40 Eridani B. I'll write Procyon because it's easier. So far we didn't need the reading. But maybe we will for the 3rd one. Barnard star and Betelgeuse are stars having similar color and surface temperature. Explain why Betelgeuse will most likely undergo a supernova, but Barnard star will not. So the answer to this is that it's bigger. But if you didn't know that, you're going to want to compare Barnard star with Betelgeuse on the reference table. So I guess we didn't need that reading, but Barnard star and Betelgeuse, so you can see Betelgeuse is way more massive. So that's what you're going for here. It is more massive. The meme is still alive. 54. Identify the geologic period when glacial Lake Albany was first formed. So we're looking for a geologic period, so that's going to be on the time scale. Identify the entire range of sand sizes. Okay, so that's going to be on the reference table. Identify the agent of erosion that forms sand dunes. So that's going to be wind. So these seem like I don't even have to read this at all again, but we'll see. Glacial Lake Albany was first formed. So it says this I had to get 15,000 years ago. So I need the geologic time period that's 15,000 years ago. So we're going to go to the reference table. Go to here. 15,000 is really recently, and they want time period. So it's going to be the quaternary period right there. And then we'll write it in. Quaterna, quaternary. And now we want all the sizes of sand. Anything weird about that? Okay, so 2 spots we can get this. I'll show you the easy spot and the hard spot. So easy spot would be here. So there's our range right there. 0.006 to 0.2. Or you can get it from here, and you can go 0.006 to 0.2. So it doesn't matter which one you put, like which spot you put that in. Still the same range. Oh, and then we got to write wind for 56. So far, these are super easy. Let's keep going. 57. Determine the height of the tide at 5 p.m. on Saturday. Okay, this is just reading a graph. Look, Saturday, 5 p.m. is between 4 and 6. So right here, so it's right there. So it's 2. 2 meters. Oh, I'm sorry. I should have showed you. Look, it goes up to the graph and then to the left. So there's where I'm getting the 2. Sometimes I just go fast assuming people know how to read the graph. 2.0? You could just write 2, doesn't matter. Predict the time of the next high tide on Monday. Okay, so first we got to see how far apart these high tides are, because this is Sunday, so we need to get the next one, right? So we got to figure this one's at about 8 a.m. and this high tide's about 9 a.m., right? Oh no, 9 p.m. So it looks like on this graph, it's about 13 hours. In real life, it's 12 hours and 26 minutes. So that's if you memorize that it's about 6 hours and 13 minutes between a high tide and a low tide. So that's reading the graph correctly, and with background knowledge, it reinforces me being right about that gap. But if you didn't know that, you could just, the peaks are the high tides and the troughs are the low tides. So now we just want 13 hours after 9 p.m. So 12 hours is going to be 9 a.m. So then another hour is about 10 a.m. So I would say they're going to take between 9 and 10 a.m. as possible answers for that one. But remember, you're just going to commit to one because it says predict the time, not a range of time. Forces that cause the tides, that's just a memorize. It's gravitational force of the moon, but the force is just gravity. We are cruising through these. 59, 60, here we go. All right, we got insolation, which is sunlight being absorbed and heats the Earth's surface, and then some is getting radiated out and then bounced off the clouds, reflecting, and some clouds trapping the heat. So it's like the greenhouse effect sort of thing. Describe how the thickness of a cloud cover at a location affects the amount of solar radiation reaching the Earth's surface. So if there's a thicker cloud, less radiation is going to hit the Earth's surface. So we'll be like thicker cloud equals less radiation because it's going to block the sun. That's why it's a little chillier on a cloudy day. State the name of the temperature zone where most clouds form. So that's going to be, if you don't have it memorized, if you go here, the water vapor content makes all the weather in the clouds, and that's mostly in the troposphere, which is the bottommost layer. So that's going to be troposphere. So far, easy peasy. Keep going. 62. All right, I'm seeing a tilt towards the sun. I didn't even look at the question. So I know this is the summer solstice automatically, June 21st. Let's see what it says. On the diagram, shade the portion that represents the nighttime. Okay, the sun's on the right, so nighttime is going to be half the Earth on the left. So you're going to want to go like this. Ideally, you want the full Arctic circle should be on the sun side, and the full Antarctic circle should be on the night side. So really, like, we want that shaded to show that the Antarctic circle is getting 24 hours of darkness, and the Arctic circle is getting 24 hours of daylight. So that's going to be that. Identify the season that's beginning. We already said it. It's summer. Because it's tilted towards the sun. 64. State the number of daylight hours that an observer at the equator would experience on this day. Equator always gets 12 hours throughout the whole year. So you don't even have to think about that. Every day of the year is 12. Compared to the summer and winter temperatures, describe how New York State's summer and winter would change if the rotational axis was tilted more. So if you're going to tilt more towards the sun, we're going to have hotter summers and colder winters. It's more extreme. So summers will be hotter, winters will be colder. If it was tilted less, you'd have the opposite. So straight up and down would be like cooler summers, warmer winters. 66. Okay, we have some reading. It's about limestone and rocks and temperatures and minerals and great. Well, let's just see what the questions are. Oh, we got a map, latitude and longitude, a distance here. Okay. Identify the process that recrystallizes rock and limestone into wollastonite using heat and pressure. So heat and pressure automatically is metamorphic rock. So that's going to be metamorphism, or yeah, probably just metamorphism. That's what I would write. So you can go to your rock cycle. And right here, and you find heat and pressure right there. Look, and or metamorphism. So that's going to be your process. Okay. 67. What do we got? Identify one mineral other than wollastonite that's used in ceramics. Okay, so this is so easy. We're just going to go to our mineral chart and look for ceramics. Mineral chart. Okay, ceramics uses. Ceramics. Oh, right there. Talc. Anyone else? Ceramics. Yep. Potassium feldspar, ceramics, plagioclase feldspar. So 3 answers for that one. And guess what? I'm going to write talc because it's the shortest one. 68. New York State landscape region in which Plattsburgh's located? What? This is easy. Go find Plattsburgh. So we're going to rotate this page 3. Sorry. Okay. Plattsburgh right here. So top right hand corner. And then we're going to find that exact top right spot on page 2. So Champlain Lowlands. It's up there. All right. Oh boy, next question's a graph. Boo. I don't feel like plotting a graph. All right, let's see. Construct a line graph by plotting the infiltration rates for the 5 bead diameters listed in the table. Connect the 5 points with a line. All right, what's the other ones? Infiltration rate and bead diameter. Okay, that's this and this. Okay, so 0.4, 18. But if you want to skip me plotting the graph, just fast forward this. 0.4, this is 0.1, 0.2, 0.3, 0.4, up to 18. This is by 1s, 15, 16, 17, 18 right there. Okay, 1.0 is 25, so that's right here. And then we got 2.1 is 31, so 2.1 is 31 right there. And then we got 3.5 is 34, 3.5 is 34. At least the grid is like easy to figure out. And 5 is 36. And then we're going to connect. So don't connect to 0 or anything like that. Just connect the dots that you have. My line is going to be so trash because I'm on a computer. Now, on the regions, make sure your dots are pretty big. Make sure your line doesn't blend in with your dots. That's really bad. We want the dots to be seen. I think this one's messed up now that I just made that bigger. What's the second point? 25? Yeah, I mean, that should be like here. Okay. I mean, pretty easy graph. So it should just be that. Okay, 70, state the relationship between increasing bead size and the amount of water retained. So retention's here. So as you can see, increasing bead size, less water retained. So the relationship is going to be inverse. You could write indirect. You can write as bead size increases, retention decreases, however you want to write it. I'm going to write inverse. Oh boy, a profile. Okay. So I'm not going to do the profile on here. So, I mean, I'll estimate it for you. On the grid below, we want A to B because it's just annoying for me to have to do that on a computer. So let's just see A to B. So A is going to be, where's this contour interval is what? What do these go up by? Does it tell us? No. So 20, 40, oh, they go up by 20s. So it's going to be 0, 20, 40, 60, 60, 40, 20, 0. So it's just going to be a mountain. So this is going to be something. Is this a lake? It's a lake. This is depth. So it's going to go down. So, oh yeah, they labeled it down. So that's fine. So it should be like this. I'm going to really estimate this for you guys. So you would get a piece of lined paper and mark it like correctly. But your answer would be something like this with a little trough down there with there and there. So again, that is not accurate. If you're wondering how to do profiles, just go watch my profile video. For time's sake here, that's how I'm going to do it. All right, 72. State one possible water depth at sea. So look, if this is 80, this is inside the 80 and not 100, so your range of possible numbers for C is going to be between 81 and 99. So we could just put 85. Okay, 73. What do we got here? Astronomy, yay. On the diagram in your answer book, place... Oh, I hope we don't have to graph this. Place an X on the moon's orbit to show the approximate position of the moon on day 5. Day 5. The lighted portion of visible is 49, so it's like a half moon. This is a weird question. What do we got here? Lighted portion of the moon visible. Is there 2 spots this could be? Could it be a first quarter or a third quarter? Because it's half? Why? Are we assuming? Oh. Yeah, has to be third quarter because we're dropping in light. That is tricky. Tricky. This is hard. 73 was a tricky question. So third quarter moon, if new moon is here and we're going this way, 3/4 of the way around, your X should be here. Yeah, that one was hard. State the number of days it takes the moon to complete one cycle of phases from a full moon to full moon. That you have to remember. It's a memorized 29.5 days to go through a full cycle of phases. That's not on the reference table. Explain how the data provided evidence that the moon has an elliptical orbit. It's because at some points it's closer to the Earth and some point it's further away, right here. So if it was a perfect circle, this would be an equal distance constantly. So we could just say some points are closer and further away. You could say the points aren't all equal. They're not all equal distance away. Something like that is good. All right, so far the only hard question was that moon plot X, 73. All right, 76. Surface air temperature on the map. Draw the 70-degree isotherm. Okay, so we're going to find all of our 70s. There's 70 here. Start linking some of these. Between 69 and 78, get this one. Between 64 and 74, get here. Here. Well, this is kind of weird. Here. 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 Yeah. And then here, go through here, grab this guy. This is a kind of a harder map, honestly. 70, and then here. So that's how I would do it. This part here particularly is tricky right there. If to miss that 72 right there would be completely wrong. And I like to go to the edge of the box. You know, you're not going to get that wrong. You can end it technically at the end of the United States, and that would be fine too. The lowest temperatures on the surface area map are inside the 40. This region is part of the Rocky Mountains. What climate factor is why it's cold? It's because it's mountains. It's tall. So it's elevation. That's the climate factor that makes it cold. They're tall. You could even say they're high up. That's fine. All right, 78. What evidence on October 25th extreme storms and wind map indicate that location Z has a dew point that's close to the air temperature? Okay, anything where the dew point is close to the air temperature, relative humidity is 100%. You could also say there's precipitation. Anything like that is going to say the air temperature is close to the dew point. But let's check the map. October 25th, and we're looking at place Z. What's the shaded area mean? The shaded portions on the 2 extreme storms and winds show the areas where extreme storms and winds, including tornadoes, were forecasted. So Z is in the area where there's extreme wind? Z is in the shaded area? Is that literally all you have to write? Yeah, I mean, Z is in the extreme wind zone. Something like that. $79. Other than stocking up on food and water, 2 emergency actions that should be taken in order to prevent loss of life and property where these tornadoes would be. So we want to get in a basement, and a first aid kit would probably be good. that would prevent loss of life. So get in a basement. There's probably a lot of answers for this, but first aid would be like your best bet for loss of life. Something to do with medicine, a generator, emergency warning system, like have a radio or something like that. Anything that's probably good. All right, 5 more questions. One piece of evidence shown in the diagram that leads to the inference that the crustal movement occurred in this region. There's a fault. So these layers are not lined up anymore. So that's going to mean that the area shifted. So you could say there's a fault, or the layers are not lined up. I'm going to say there was a fault. All right, 81. Place the letters of the following rock units in the fault in order from oldest to youngest. C, D, E, fault X. Okay, let's see. C, D, E, X. So we want C, D, E, X. All right, let's look at this thing. So D came after E. So it has to go like this because E is under it. And then they all came after the fault because this is going over the fault line here. So that has to be, X has to be there. And then C is also under it. So the question is C before X? Or is X before C? Oh, so C has to be the first thing because it's not faulted. At least that we could... Oh, wait, it is. Yeah, look, it is because C is also here. So C had to be there first. Then the fault happened, and then E, and then D. This is the right answer. That one's kind of hard. I would say this question was hard. Just because of this area here is like kind of hard to tell. That because the fault is like very... I don't know. It was just kind of hard. All right. Rock unit G formed during the late Cambrian period, and rock unit J formed during the early Ordovician period. Identify the name of one index fossil that could be found in rock unit H. Okay, let's think about this. Cambrian and Ordovician. So Cambrian, Ordovician. So we need to know what layers in between those first. So let's go here. Gotta rotate this so everyone can see. Rotate, rotate, rotate. Okay. So Cambrian and Ordovician right here. So we need a index fossil, which are these letters between the two, right? Okay, so let's go look. So it's going to be the dark line and one line above it. Dark line, one line above it. So it's going to be J. It's the only one that's on the, like, in the area in between. So J, so it's probably going to be this guy. Tetragraptus. That's who I would pick. All right, 83. Ooh, latitude and longitude. Let's see. Okay. What's the question? Determine the latitude and longitude of the Sierra Madera crater. It's right there. And what do they want us to do? To the nearest whole degree? Okay, yeah. I was going to say this is estimated. So it's between 32 and 30 north. So 31 degrees north, comma, and then right here is 103 degrees west. Wow, that is super duper basic. 31 north, 103. You got to put your directions on that or you won't get the credit. 84. State the name of the crater that has a diameter equal to the straight line distance in kilometers between Ithaca and Slide Mountain. Oh my gosh. Why, New York? Why? So we got to go Ithaca to Slide Mountain. We got to rotate this. This is terrible. You got to use this scale down here. And we got to go from Ithaca, which is here. Oh my gosh. to Slide Mountain. Where is Slide Mountain? Oops. Ithaca, or ignore that first line. So that distance there. And they want that in kilometers. So I can't estimate this on a computer very well, so it looks like 2 of those. I would say it's about 160 kilometers just by eyeballing it, but you would measure that. So you get a piece of scrap paper, measure that line right there, use the kilometers. I'm going to see if 160 works. Where is this? 160 kilometers? Yeah, so it'd be this one. It'd probably be the one near 180. The other ones are way not even close. So it's this one. CHICXULUB. Okay. That one's not hard. It's just like annoying and kind of weird. So that one's kind of weird. Identify one type of solar system object that could have impacted the Earth's surface to create any of these. A crater. It could be like a meteor, an asteroid. I would say we'll put an asteroid, meteor, something like that. Whichever one. All right, that's all the questions. I would say there's like 3 on there. So I would say this test overall, I would rate it my ranking of in terms of 10 being the hardest Regents ever to 1 being the easiest. I would say this is like a 4. I would say there's some like weird questions on there, but overall this was very straightforward. So anyway, I hope that helps. If you stuck with me to the end, thank you, and good luck on your tests. And if you have any questions, let me know in the comments. All right, see you later. Bye.